Tell me about your background and what led you to Microsoft Research.
So I was finishing up my graduate work, really excited about going off to become a professor with a lifelong goal of really getting to the core of human and machine intelligence. I think they're both based in the same thing. When we got a call from Nathan Myhrvold, I and two colleagues who had a startup together, we had a startup in our pocket while we were working on our dissertations at Stanford. And the startup was doing fabulous, fun work in AI for several companies, including the NASA Mission Control Center, diagnosing space shuttle failures. So we were having a blast. And we came up to Microsoft, and we thought we would this was just yet another company or consulting job, and came up with our sport coats on and gave a talk. And Nathan Myhrvold and Rick Rashid said, well, you're going to join us, right? We'd like you to help us build Microsoft Research. Microsoft Research? Now tell me more about this. And we were kind of like, well, I'm not so sure about this. There were a few people that, at Building 9 at Microsoft. And, but we ended up being convinced to just take a flyer and try this out. I thought at the time I'd stay 6 months max. But it's been a total blast. It's like I view Microsoft Research and Microsoft as a startup, basically. I've kept that in my mind. We're just pushing really hard, doing startup-like things, trying to spawn new ideas and new services, but now we could sort of have this lever to the horizon, fulcrum at the horizon, really having an impact in the world, a much bigger impact than we would have at our startup. And Microsoft Research has become better than any university I could imagine. The colleagues here, the size and scope, the nature of the projects we can do, and the scholarship rivals or goes beyond any university computer science department.
What was your first computer?
It's interesting. My first computer that I would call a computer was something that I built. And it's not the kind of thing you would think when you hear about a whiz kid building a computer of some kind with tubes or transistors and relays. Mine was built out of cardboard. I built a cardboard adding machine with, when I say cardboard, I out of cardboard to cut these disks with grooves that would rotate and hit one another, do the carrying and the adding. I was very proud of this system, and I think I had some trouble when it got a little bit warped and wet.
Yeah.
But it wasn't made for all-weather computing, that's for sure.
How do you define AI? Is it all Jetsons robots cooking our dinner? Is it a disembodied head in the cloud? How do you define what AI actually is?
Well, I'd like to think that artificial intelligence is the explicit and direct pursuit of an understanding of principles, the computational, the mathematical principles underlying thought and intelligent behavior. It's pretty clear to me that as you hear me, as you listen to me, the ability to hear, to be here, to have goals beyond our meeting today, to sense sitting in this chair is computational. Now, I am mystified as to how tangles of neurons could pull that off, but let's put that to the side right now. I still believe that this is computational and that it's algorithmic, and that we need to continue to pursue both the foundations and the principles, as well as the software and the hardware that would enable us to do this on our own as human engineers and scientists. The implications of us pushing towards computer systems that can act in a more intelligent way and do more and more of the things that we thought for thousands of years, these centuries, could only be done by people, will have incredible implications for humanity. It's easy to imagine how if we had automated if we had automated some of the services and roles that people play, what it might mean to education and tutoring, to design, to the actual endeavor of science, to have machine intelligence helping us to interpret data, to design experiments. You almost can see an exponentiation of what it is we would know about the world, about challenges like global warming. And then in daily life, I have to think about this rising set of expectations coupled with a very fast-paced set of what's normal. You know, what is it that we consider normal now that would be viewed as complete magic, only explained by spiritual powers, powers that come from the beyond? If they would see something, for example, like a cell phone, and one or more of your apps, a television set, the fact that we're getting, you know, live feeds from a rover spinning through craters on Mars. And then when it comes to AI, people have often said that AI has provided us with so many things over the years, but once it becomes part of the background and part of the norm, we don't view it as AI anymore, and we look for the next thing coming from AI that's really smart. And I'd like to point out that everybody now navigates on their car navigation system or on their smartphone with an algorithm called the A-star algorithm, which makes it possible to cut through this incredibly difficult, huge search space of all possible routes between point A and point B very, very quickly with a heuristic evaluation function and some provable properties about how the algorithm is admissible, as it's called. But it's not considered magic anymore. It's considered, Eric, did you put the address in yet? Well, we had all this time and now we're rushed. Okay, I'll do it right now. And there's no notion of like, wow, let's reflect about the work of Peter Hart and others in coming up with this A-star algorithm to let us even do this.
Yeah. What is a surprise model and what is surprise forecasting?
So we've done a number of pieces of work that bring the human being into the equation with machine intelligence. And I often like to use the phrase complementary computing to refer to the ecosystem of you, the smart person, with all your abilities and desires and goals and intentions someday, surrounded by one or more really, really smart AI systems that understands how to best complement your abilities, decision making, and even help fill in some of your blind spots by learning deeply about you as well as as about people in general. It's been fascinating to sort of take the searchlight of, let's say, machine learning, learning from data model to predict and to infer, the spotlight of machine learning, for example, and point it at human minds and to ask the question, can we learn algorithmically about when it is that a person will forget something? Can we learn moments when that thing forgotten is actually relevant and should be remembered? Separate model, relevance. I mean, you forget many things that you don't need to know about, and you can imagine how much a nuisance it would be to hear about these things all the time. Mm-hmm. Hey, that guy in your first grade class, his name was Timmy. I go, I forgot that, but I don't need to know that right now. So you need to have a model of relevance and a model of forgetting. But a third model you really need, speaking of my last comment, is a model of the cost of interrupting you to tell you something. But if you build 3 of these models, each very human-centric, and and requires data about people and their lives, and have them strung together in a coherent way, you end up with a symphony of three models that reason about how to best remind you at the right time in the most non-invasive way. And that kind of a complementary computing device can be magical if done well, if engineered well. In the same way, we can reason about what events coming in the future might surprise you. What is it about something that might happen that a large-scale computing system might be able to predict as very likely? At the same time, a user model predicting things that you know will see it's not there, or it's predicted as low probability. And given these two different viewpoints, the user model, what you believe or might expect, and what the system expects, and a model of relevance knows, I better tell Bill about this surprise coming.
What is something in the last 12 months that surprised you about AI?
That's a great question. Well, I won't call it surprising, but I mean, I almost expected it. I'm very excited to see over the last, 3 to 5 years, the growing consensus that the next, if not last, enduring a competitive battlefield among major IT companies will be artificial intelligence. The notion that systems that can think, listen, hear, collect data from thousands of user experiences and resynthesize it back to enhance its services over time is central, has come to the forefront now of even the lay public. The notion now that we have Cortana and Siri and Google Now setting up a competitive tournament for where's the best intelligent assistant going to come from, who has the best services, the most human-oriented approach to complementing people out there. And that kind of competition is going to heat up the research and investment and bring it more into the spotlight.
How much of the work at Microsoft Research revolves around AI?
Well, if you went and looked at the roster of Microsoft Research as to who's doing what, you wouldn't realize right away how big AI is. A few years ago, I went and I sort of counted people, scientists, what they were doing. And if you consider AI to be broad the way I do, which AI includes machine learning, machine vision, natural language processing, speech recognition, reasoning systems, systems that do planning, and beyond, over a quarter of all attention and resources at Microsoft Research is focused on machine intelligence, AI, right now.
In the future, do you believe that a computer will have an original thought? Can they think outside of their algorithms?
Absolutely. I often say when talking to folks that AI systems can literally be creative. They can identify new categories, new concepts, synthesize new approaches to challenge problems, come up with new ideas, even new distinctions that weren't told to them originally. For example, deep learning methods actually induce structure, new kinds of observations and features that come to life. They learn to recognize certain geometric structures in images, all the way up to certain kinds of people or cars, all on their own. So I would say that kind of technology is extremely creative. It has the foundations of creativity as part of its fabric.
Do you think that AIs in the future will be bored by human conversations? Would they want to have conversations between each other, and what would that look like?
Well, now you're asking, you're getting into this whole realm of intelligence that might one day more or less feel like us, have human sensitivities and awareness, even consciousness. I fundamentally believe that that vision, that world, those machines are attainable, because I believe that, as I said earlier, this is what's going on in our own minds, and therefore it's not off the table. The question arises, if and when this happens, what that will mean to the relationship between humans and machines more generally. There have also been concerns about the long-term prospect that we lose control of certain kinds of intelligences. I fundamentally don't think that's going to happen. I think that we'll be very proactive in terms of how we field AI systems, and that in the end, we'll be able to get incredible benefits from machine intelligence in all realms of life, from science to education to economics to daily life.
What does the future of AI look like, say, 15, 20 years out?
Oh, I see that 15 to 20 years from now, I see us all working quite closely with machine intelligence in our daily life in terms of personal assistance, reminders, education designed just for us, that's lifelong, new kinds of entertainment experiences with the right kind of competitor, and where game AI becomes real AI. I think it'll be quite exciting.
Is there a movie that you think accurately portrays AI, or something that you really thought they kind of nailed it?
Well, I recently saw the movie Her. I wouldn't call it necessarily an accurate portrayal of AI, but I loved certain things about that movie in terms of this notion of a relationship that we might all have someday with a machine intelligence of some kind that's working on our behalf, that knows us well. I love some of the design aspects of having a little flip phone and sharing challenge problems about a mountainside with a system that's entertaining and interesting and engaging. And I loved the notion of what a singularity is. I mean, these systems will have very little time for us if they really became bright, and flying off together and having a grand old time thinking about wisdom and the world of intelligent thinking and thought is probably more of what a singularity might be like someday, should there be something like that. Mm-hmm. I have to say that in seeing the movie Her, I thought back to my own life now. Now, I have an intelligent assistant that we've built at Microsoft Research that spans across my devices. That's part of a project called Situated Interaction. So when I come in the morning, I walk to my office, and at my door is Monica, my virtual assistant. And she greets me, she recognizes me, I get a cute little smile, which is very endearing, I think. And I get an update about the day, who's been there, what's happening, and I head into my office to work. And then while I'm working, heads down, I hear her talking to people at my door, saying it's not the right time right now. How about 10 minutes? I'll check back and let you know. I'll close the window, finish scheduling a flight, and they hear her out there saying, now's a good time. Oh, come on in. People say, wow, that's incredible. Yeah. And that kind of thing, I think, will be more commonplace someday. We'll all have our Monicas, and they'll be personalized the way my system is. In my case, Monica has access to over 10 years of data about my comings and goings, about my nuances, about when I'm available, how long it'll take me to get back, given what my calendar says, and does a great job with sharing just the right amount of that information with people who might come by my door to convince them and to be useful to them that she's a very brilliant, close personal assistant that knows how to work with people and knows how to make sure that my life is better and that I coordinate well with my colleagues. And I do have this analogy in my mind of a symphony playing, of competencies that are generating a fluid user experience when someone actually works with the system. And I believe that someday we'll find out, and some people believe this now, that our own minds, as fluid and solitary as they feel, are really a symphony of many components, of separate abilities and competencies that are wrapped together in a very, very beautiful way through software that's coordinating, controlling, and distributing effort.
You came up with something called bounded optimality. Can you explain what that is?
Well, we all try to do a great job in life, making good decisions under uncertainty. We often don't know exactly what's going on in the world. We often have to make decisions by a certain time. If we delay too long, our actions sometimes aren't as valuable. We might miss the boat. So there's a time criticality in our decisions as well, where a great decision made early is often the best. There's been a long discourse, a long reflection over a period of decades about what it means to be a rational being, to make the right decisions, to do the best information gathering before you make decisions. And it's difficult to be perfect given bounds on our ability to know, bounds on our ability to think, limited computational power. And I pushed on this notion of bounded optimality, which was, hey, can a system learn itself enough, understand its power and its abilities well enough to know how best to think about acting in the world, how best to come up with the best decisions, if and when to act, based on all its research constraints. And if you turn this big crank and optimize thinking itself, you have what you might call a bounded optimal decision, where a bigger computer or having more time would tell you that wasn't exactly the right thing. But to say that I did exactly the right thing given the uncertainty and my own computational limitations means something, and that's bounded optimality. And it's something to be proud of for a system.
What role does machine learning play in artificial intelligence?
There's been a lot of excitement about machine learning lately, a lot of banter about it. It's actually been in the press quite a bit, so much so that you might think that machine learning is machine intelligence. Certainly learning and our power to learn from data now, given our newfound access to large amounts of data, is big news and very helpful in AI, and is a pillar of artificial intelligence. But it alone is not reasoning, thinking, acting, seeing. And AI, foundations of intelligent thought and behavior, really require learning, planning, decision-making, vision, natural language, many different competencies, often drawn from different areas of computer science, sub-disciplines of AI. Learning is fabulous, and learning abilities are helping, and the prowess there in all these subfields, and it might even someday provide the glue to help put together the symphony of many instruments. But it's one piece of a bigger puzzle.
How should developers think about AI and machine learning in what they do today and how they prepare for the future?
It's really a great question to think through what developments and needs and goals in machine intelligence and how important they are mean for developers, for engineers. Certainly it's important for engineers to have a good sense for the best tools that are out there for taking data and transforming the data into what we call predictive or inferential models that can give us probabilities of outcomes, for example, or classes, that can convert data into insights that can be used, displayed to help with decision making at all levels of industry and in the hands of consumers as well. So I would suggest that people need to sort of learn about AI. There's a lot of material out there right now, and different kinds of tool sets, some that come from Microsoft, like our Azure Machine Learning, cloud-based learning tool set. others that are out there as open source solutions. I think that it's important to start learning about distributed systems, where in a world now where as we scale up machine learning and other kinds of machine intelligence, we're starting to draw upon the power of many machines, not just multi-core, but whole data centers. And to understand what's going on with the engineering of these systems is very, very interesting and challenging. So getting a sense for the system side of AI I think is also important. It's interesting to think about how one starts to cobble together systems that can do several things. So one whole area that's very important for developers, I think, to be thinking about is what I would call multimodal systems. Systems that can take in different streams of information, a user's calendar, a visual signal, some speech, pen, and touch. How do you coordinate these things? How do you write software that is open to multiple sensory perceptual inputs and data inputs all at the same time? It's worth thinking deeply about and growing skills in that space.
How do you determine the right balance between AI benefit and the creepiness factor, like the boundaries that I have as a person with regard to privacy?
Well, I think that privacy in this world of machine learning and machine intelligence is going to only get more important. At the same time, people's toleration is growing to sharing. It's unclear what our kids are going to worry about when they become adults, and what they'll tell their grandkids about about data, when the grandkids might care even less. But I actually don't believe that we're going in that way. I think that people will care about privacy, and certain things will continue to be sensitive. And I believe that some of the answers to handling privacy will come from AI itself. So I believe that AI will provide us with answers to privacy and solutions. For example, we've been working with systems that can figure out exactly what information they would best need to provide the best service for a population of users, and at the same time then limit the incursion on any particular user. These approaches are we call principles of community sensing that really execute on the dream of altruistic access of data for the whole, for the common good, that know how to limit data that's selected and know how to randomize where the data comes from so that no particular user is under any significant privacy risk, as we call it. You might be told, for example, in using this service, you have a 1 in 10,000 chance of having a query ever looked at. We're told that we can get enough data from this population, but each person is only has to worry about as much worry as they worry about getting hit by a bolt of lightning. It's so rare. Yet we have enough to do the right thing with the data. So I believe that machine learning, reasoning, and AI more generally will be central in providing great tools for ensuring the privacy of folks at the same time as allowing services to acquire the data anonymously or with only low probabilities of risk to any particular person and do the right thing with that data. We have some really great work in that space. Come to our website and read about that work.
Thank you so much for talking to us today, Eric.
Oh, it's been great hanging out with you.